As Archimedes doubled the sides of the polygon inside the circle, then added up the perimeter and divided it by 2 to get a ratio to go with the radius, he didn't realize something. He didn't take into effect the account of God. Wisdom belongs to the Lord, and you don't get the truth without going through Him. And what he didn't realize was there's a thing that people like to call geodesics. You ask, what is geodesics? Geodesics is when the shortest distance between 2 points is not a straight line. It's a curve. And in the true 3.6-inch circle, it proves that. But geodesics happens all the way up till 12.2554695 degrees. At that point, the ratio from inside to curve is 1:1. But everything below 12.2554695 degrees, the curve is actually a shorter distance than the straight line connecting the 2 points. Whenever Archimedes doubled the sides to 12, this line would run through the 15-degree portion of the circle, and it would give you a perimeter ratio of 3.10582. That's just below the true pi value. So after he would double the sides again to 24, that line would then run through 7.5 degrees, which is below the 12.2554695 degrees, where the curve is shorter than the straight line inside. So after he doubled it again from 12 to 24, the curve was shorter than the straight line measuring it. So he was getting a bigger answer than what actually is the value of the circumference of a circle. See, he got to 3.13262 at 24 sides. Whenever you take 180 degrees and divide it by pi, it's telling you how many degrees in 1 inch, but it's also creating the radius of a circle. And that radius is 57.735026919. And in that circle, at 12 degrees, 12.2554695 degrees, it is 12.2554695 inches tall. It's 1:1. And everything below this on that circle, it's a 3.6-inch circle. That's why we have 360 degrees in a circle. The curve is shorter than the straight.